All right, I'm going to back up and start at the beginning of this section here. This is about the effects of gravity on erosion and deposition. So as a review, it says gravity is an agent of erosion and deposition, which means that gravity is one force that can cause erosion and deposition. Gravity can influence water going downstream, ice as in glacial movement, and large masses of rocks and soils to move down slope. So mass movement is the movement of any material in large amounts, such as rock, soil, or snow, downslope, due to the agent of gravity. Rockfalls are one type of mass movement considered a rapid mass movement because a rockfall can happen suddenly and rapidly and be very dangerous. So rockfalls are when loose rocks fall down a steep slope. And the rocks that fall can range in size from small to large. And here's an example of rocks falling down a steep slope. So over time, gravity will increase the chances of them falling. Landslides are sudden and rapid movements of a large amount of material down slope. The most common type of landslide is called a slump, and it occurs when a huge block of land becomes detached and slides downhill. So landslides are on a little bigger scale than a rock fall. So here's an example of just this whole side of this hill over a town just collapsing and sliding right into the town, along with everything that was on the side of the hillside and just leveling out everything below. A mud flow is another example of a mass movement, another rapid mass movement. Mud flows can happen quickly as well without any warning. So we have a large amount of water mixing with soil and rock. And this would be more common on a mountainside or mountain region. So it usually occurs after a very long dry season. So that will make the land pretty vulnerable. And then it's followed by very heavy rains that's going to make these huge mud flows. And those can happen along rivers and things too. So probably accompanied with flooding. These can be very dangerous. It can make the mud flow like a river and just make you lose your balance. Then you can't regain that. So I've seen these on the news. They look pretty terrible. Here's a picture of a mud flow in an unpopulated region, but this also looks dried up. At the time that happened, it was probably a little faster and rapid. So that was the last thing with gravity. So we move on to wave energy and shoreline erosion and deposition. So here we're talking specifically about water waves. So waves crashing into rocks over long periods of time breaks the rock into smaller and smaller pieces until sand is formed. So waves crashing into rocks over time, breaking the rock into pieces, that is your definition of weathering. And then the small fragments of sand coming off of it and moving it would be your erosion. So waves are what build up shorelines. A shoreline is defined as the boundary between land and a body of water. So a shoreline can exist at oceans, around a lake, by a river, any body of water where the energy from the water can crash into the side and weather away the land. The ripples produced by the ocean on the surface due to the energy it's carrying is called a wave. So the energy is in the wind, and that gets transferred to the surface of the ocean and produces a ripple called a wave. And the size of the wave depends on how hard the wind is blowing and how long the wind is blowing, which hopefully seems like a pretty obvious statement. Winds that result from summer hurricanes and severe winter storms can produce waves so large that they can cause dramatic shoreline erosion. So usually shoreline erosion is a continuous process and gradual, but it can be a sudden change as well if it's accompanied with hurricanes and winter storms. So here's an example of some pretty strong waves hitting the cliffside, and you can see a bunch of different forms of weathering and erosion taking place here. You can see all the layering of the rocks, the coloration of the rocks. You can see that it's kind of carved out pieces of the rock that go inward. Another thing, this is so zoomed in you don't see, it's kind of like a bottleneck effect. It's probably wider way back here, and then it narrows, and so all that wave energy gets narrowed in here and causes really strong waves hitting this. And imagine that's happening all the time. So some pretty severe weathering taking place at this area. So waves are used to shape a shoreline. Wave erosion produces a variety of features. So I'm going to show you several different features that can exist along a shoreline. And a lot of this happens during storms or during a lot of wind and hurricanes, or gradually over time. So I'm going to show you sea cliffs. Those are formed when waves erode and undercut rock to produce a steep slope. And I'll show you the sea cliffs, and I'll show you a lot of other features that form from wave erosion. You're probably not going to see all of these at once, but this picture is just showing you a bunch at once. So if you ever make a trip to the ocean, it wouldn't be uncommon to see things like this. So I'll start over here on the left side. Here's a sea stack. And there's an animated picture of one and an actual photograph of a sea stack. A sea stack is an offshore column of resistant rock, so something that's a little sturdier than the rest that resisted all the wave force. It was once connected to the mainland, but the waves eroded away the rest of it and left behind this column of rock called a sea stack. So when you guys were looking at your pictures yesterday in class, in that Google slideshow, there's a picture of a sea stack or two. The ocean wasn't there anymore. The ocean had dried up, but you could still see where it had been many years later. Actually, I'll do sea caves and then sea arches. So a sea cave is a large hole that's cut into the mainland. It's common in cliffs that are made of sedimentary rock. So it goes in a little ways, but then if it keeps eroding and eroding all the way through, then you have a sea arch. So a sea arch comes from a sea cave.